Saturn, the planet with beautiful rings floating in the night sky. Its appearance is not merely elegant. In fact, Saturn is a giant mirror that reflects the mysteries of the universe. The magnificent rings that adorn Saturn are not there for eternity. Astonishingly, those majestic rings are, at this very moment, disappearing. Why is Saturn, and Saturn alone, facing such a strange phenomenon? What secrets are hidden within this planet, which possesses features unseen on other worlds? In this video, we will delve deep into the mysteries of the planet Saturn and embark on a journey of exploration together with you. First, why is Saturn such an anomalous presence? While other gas giants have faint rings, Saturn's are orders of magnitude larger and clearer. If those beautiful, jewel-like rings were to one day vanish, we might be witnessing a truly miraculous moment in time. In the main feature, we will trace the past, present, and future of Saturn to uncover its true nature. Now, let the curtain rise on the story of Saturn, a microcosm of the universe, the mysterious planet humanity encountered. Our story begins in the early 17th century with the first observation of Saturn by Galileo Galilei. In the year 1610, Galileo observed Saturn for the first time with his self-made telescope. However, because the telescope's performance was poor, he couldn't understand what Saturn's rings were. Galileo recorded that Saturn had ear-like appendages, what he saw as bumps on either side. Galileo called Saturn's ears. At the time, he didn't think they were rings, but rather speculated that Saturn had moons, giant moons, on either side of it. However, when he looked at Saturn again 2 years later, in 1612, those ears had vanished. Galileo was greatly perplexed. In reality, that was the year Saturn's rings were edge-on from Earth's perspective. And because only the side of the thin rings was visible, they became invisible through his telescope. Then, 2 years after that, when he observed Saturn again, the ears had reappeared. Galileo concluded that Saturn seemed to have arms, and he passed away without ever solving the mystery of the rings. The one who unraveled this mystery was the Dutchman Cassini-Huygens in 1659. Huygens observed Saturn with an improved telescope and correctly inferred that Saturn is surrounded by a thin, flat ring. He also discovered Saturn's largest moon, Titan. Later, the Italian-French astronomer Giovanni Cassini discovered a thin gap within the rings. In 1675, the Cassini division and also discovered several moons, Iapetus, Rhea, Tethys, and Dione. This history shows how Saturn has left a strong impression on humanity as a mysterious planet with rings. After this history, modern humanity finally sent a probe to Saturn, allowing us to directly touch its mysteries. This was the Cassini-Huygens mission, a joint project of NASA and the ESA, launched from Earth in 1997. Cassini reached the Saturnian system in 2004 and went on to observe Saturn and its moons in detail for 13 years. The data sent back by Cassini was nothing short of shocking. For example, on Saturn's moon, Enceladus, a small, icy moon just 500 kilometers in diameter, it discovered geysers, fountains indicating the presence of liquid water. It also confirmed that on the largest moon, Titan, there exist methane rain, rivers, and lakes. Furthermore, It revealed aspects we never knew, from the internal structure of Saturn itself to the detailed structure of its rings. Thanks to Cassini's discoveries, it became clear that Saturn is not just a beautiful planet, but a small universe filled with wonders. Saturn had been shrouded in mystery since the time of Galileo, but even modern exploration has raised new questions one after another. For instance, when and how were Saturn's rings formed? And how long will they exist? Does Saturn have a distinct core, like terrestrial planets? Is there life on Saturn's moons? These are all questions that ignite human curiosity. Through this chapter, we have looked back on humanity's encounter with the mysterious planet Saturn and touched upon its mystique. Saturn was also a mythological figure in ancient times, the Roman god of agriculture and time, Saturnus, and the Greek god Cronus correspond to the planet Saturn. In mythology, Cronus is famous for swallowing his own children, which is said to symbolize how time consumes all things. At the same time, the tale of his swallowed child, Zeus, growing up to overthrow his father and rule the world, is said to represent the cycle of destruction and rebirth. In other words, Saturn Cronus is also a symbol of destruction and regeneration, of time and fate. Keeping this mythological aspect in mind, the modern discoveries surrounding Saturn, such as the life cycle of its rings and the possibility of life on its moons, might feel as though they carry a philosophical meaning. The mystery of the rings and the countdown to their disappearance. When you think of Saturn, the first thing that comes to mind is its beautiful rings. These enormous rings, stretching about 270,000 kilometers in diameter, are Saturn's signature feature. But what are these rings really? And as mentioned at the beginning, these rings are not eternal. The structure of the rings, a collection of fine ice and rock particles. At first glance, Saturn's rings look like a single disk surrounding the planet, but they are actually a collection of countless fine particles. The main component of these particles is water ice, with some rock and dust mixed in. Their sizes range from microscopic grains to boulders, several meters across, all orbiting around Saturn's equatorial plane. The rings are divided into several bands with famous names like the A ring, B ring, and C ring. The Cassini division, discovered by Cassini in the 17th century, is the gap between the A and B rings. We now know that small moons like Pan and Daphnis exist within the rings, and their gravitational influence creates gaps, wave patterns, and density waves. In this way, the rings are a dynamic system of collected particles, acting almost like an ecosystem that interacts with Saturn's small moons. Ring formation hypotheses: satellite destruction versus primordial solar system debris. Several theories have long been proposed about how Saturn's rings were formed. There are two main competing hypotheses. The first is the satellite destruction theory. This theory suggests that a moon that once orbited Saturn, an icy moon, was destroyed for some reason, and its fragments became the rings. One scenario is that the moon was shattered by a collision with an asteroid or comet, or it's been pointed out that it might have gotten too close to Saturn and was torn apart by tidal forces. According to this theory, the rings were formed relatively recently. The second is the primordial solar system debris theory. This theory proposes that the rings were formed from the remnants of the protoplanetary disk that remained around Saturn during the early stages of the solar system's birth. In other words, the idea is that the rings have existed since Saturn was born 4.6 billion years ago. The image is that ice and dust that failed to coalesce within Saturn's gravitational sphere remained in orbit. In this case, the age of the rings would be as old as Saturn itself. For a long time, there was no decisive evidence to prove which theory was correct. However, recent research strongly suggests that Saturn's rings may not be that old. According to gravity and ring mass data measured by the Cassini probe, the mass of the rings is surprisingly small compared to Saturn itself. And it was also found that the ice in the rings is highly pure. It's not very dirty. If the rings had existed for billions of years, they should have been darkened by accumulated space dust. But in reality, they shine very brightly. This indicates that the rings may have formed as recently as 100 million years ago. This means the rings weren't there when Saturn was born, but likely appeared geologically recently, perhaps since the age of the dinosaurs. Scientists point out that perhaps Galileo and we are coincidentally living in the brief era when Saturn's rings exist. The favored scenario is a version of the satellite destruction theory, where small icy moons collided with each other, or a comet from outside the system impacted and shattered a moon into pieces. For example, it's possible that an ancient moon in the Saturnian system had an unstable orbit and collided with another, or was destroyed by a giant impact. The debris would have then scattered around Saturn and formed the rings. This theory can explain the youth of the rings. And indeed, there are moons in the Saturnian system with unusual orbits, suggesting traces of a major past event. Breaking news: the countdown to the rings' disappearance has begun. Even more surprisingly, it has become clear that Saturn's rings are highly likely to disappear in the future. According to NASA research, the ice particles of the rings are being pulled towards Saturn by its gravity and magnetic field, raining down into Saturn's atmosphere. This phenomenon is called ring rain. Voyager probes had suggested signs of it, and Cassini provided detailed data. A massive amount of water molecules and fine particles are pouring from the rings towards Saturn's equator, at a rate said to be enough to fill an Olympic-sized swimming pool in half an hour. It was estimated that if the ring rain continues at this pace, the entire ring system will be gone in about 300 million years. Furthermore, Cassini observed particle fallout directly over Saturn's equator. Considering that ring material is also falling near the equator, calculations suggest the rings could disappear in just 100 million years. From the perspective of Saturn's age of about 4.6 billion years, 100 million years is but a moment. We are the lucky generation to happen to be alive during the middle of the ring's lifespan. What will Saturn look like once the rings are gone? It's thought that it will probably become a planet with only faint rings or a little dust, much like Jupiter or Uranus today. In fact, Jupiter, Uranus, and Neptune also have faint rings, but none are as prominent as Saturn's. In a few hundred million years, Saturn may well become a similarly plain-looking planet. The fact that humanity exists in this era and can observe Saturn's spectacular rings is, from the perspective of cosmic history, nothing short of a miracle. The rings are truly a fleeting wonder. This fact raises the following question: are we humans blessed to live in the fortunate era when Saturn's rings shine so brightly? If Saturn's rings hadn't existed during the age of dinosaurs, the history of human astronomical development might have been different. Conversely, when a future cosmic civilization looks at Saturn 100 million years from now, the rings may no longer be there. The mystery and ephemeral nature of Saturn's rings may be teaching us about the impermanence of all things in the universe, the principle that everything is in a state of flux, Saturn's internal structure, the nature of an ambiguous core. Next, we turn our focus to the internal structure of Saturn itself. As a giant gas planet, Saturn's interior is completely different from a rocky planet like Earth. According to the latest research, it's possible that Saturn does not have a distinct, solid core. This is a discovery that overturns conventional wisdom, a layered structure of hydrogen and helium. Saturn is a gas planet whose main components are hydrogen, about 90%, and helium a few percent. Like Jupiter, due to its immense gravity, the pressure and temperature increase to extreme levels toward the center. In the lower layers of Saturn's atmosphere, there is a layer of liquid hydrogen, where hydrogen behaves like a liquid, and it's believed that in the deeper interior, there is a layer of metallic hydrogen, which conducts electricity like a metal. The dynamo effect occurring in this metallic hydrogen layer, the convective motion of electrically charged fluid, is what generates Saturn's intrinsic magnetic field. In fact, Saturn has a magnetic field about 580 times stronger than Earth's, though it's not as strong as Jupiter's. For a long time, it was believed that Saturn's interior had a concentric, onion-like structure. That is, a core of rock and ice at the center, surrounded by metallic hydrogen, which is in turn enveloped by liquid hydrogen and then gaseous hydrogen. However, in recent years, this image has been forced to change. Detailed analysis of the data left by the Cassini probe suggests that Saturn's core is not a clearly separated ball, but rather a soup with blurry boundaries. This is also called a fuzzy core, an ambiguous core without a distinct center. The latest simulations show no distinct core. According to a paper published in August of 2021 by a research team at the California Institute of Technology, it is highly likely that Saturn's interior does not have a core made of a lump of rock and ice, as previously assumed. Instead, they say there is a blurry, diffuse core, where heavy elements, materials, corresponding to rock and ice, gradually increase in concentration toward the center. In other words, inside Saturn, the light hydrogen and helium are not completely separated from the heavy materials. They are slowly mixing, and there is no clear boundary. Even more shockingly, it was calculated that this core is enormous, reaching about 60% of Saturn's radius. Since a planet's core was traditionally thought to be at most 10 to 20% of its total radius, this is a size that far exceeds that. The catalyst for this conclusion was seismic observation. Using Saturn's rings, the rings record wave patterns caused by minute vibrations and gravitational fluctuations from within Saturn. By analyzing the waves on the rings from Cassini's observation data, they were able to capture how Saturn's interior is slightly vibrating. It's as if Saturn itself is having an earthquake, and its vibrations are transmitted to the rings. A thorough analysis of this phenomenon revealed a pattern different from the gravitational signals that would occur if there were a heavy core inside. And they found that it could only be explained by a model where the core is blurry and spread out. Dr. Christopher Mankiewicz of the research team stated, "The structure of Saturn was previously thought to be a core of rock and ice with layers of hydrogen and helium stacked on top. But what we found is basically a blurred-out version of that structure. There is no clean boundary between the heavy and light components. The core is sloshing and mixing, so it's not a single, distinct layer. It's more like Saturn's interior is a region of sludge containing a lot of heavy material rather than a core. This discovery has had a major impact on planetary scientists, as it may apply not only to Saturn, but also to other gas giants. It's been pointed out that the cores of other giant gas planets, like Jupiter, might be similarly fuzzy. If so, theories about the formation and evolution of giant planets will also need to be revised. A completely different, ambiguous existence from terrestrial planets. Thus, it has been suggested that Saturn's internal structure is completely different from the image of planets with a distinct core. Like Earth, in the case of Earth, about half of its radius is a metallic core, inner and outer core, with clearly separated layers of a rocky mantle and a crust outside of that. But in Saturn, the boundaries change continuously, and there may not be a distinct lump called a core. It's a unique entity that could be called a coreless planet. This is also an interesting point from a philosophical perspective. We tend to think that things have a center, but Saturn is an entity where the center is ambiguous, and even the boundaries are vague. Despite being a giant ball of gas, it exists as a single celestial body that rotates, generates a magnetic field, and has moons in its tow. Its interior properties change like a gradient, and its core is not fixed. It's as if it's an entity that exists while embracing ambiguity. A day on Saturn is very short, about 10.5 hours. But its axis of rotation is related to its unique seasonal changes and magnetic field behavior. The fact that the core is blurry likely affects the fluid dynamics inside that accompany its rotation. For example, the mystery of Saturn's magnetic field being closely aligned with its axis has been a topic of debate in connection with its internal structure, as we've seen in this chapter. Saturn's interior is a bizarre world. Unlike anything on Earth, the concept of a fuzzy core teaches us about a new type of planetary image. There are diverse worlds in the universe that exceed human common sense. Saturn's internal structure is a prime example of this. These discoveries are also a major achievement of the Cassini probe, and one of the reasons why Saturn is called a microcosm of the universe. The moons that hint at the possibility of life. The Saturnian system has more than 80 known moons. Among them are fascinating celestial bodies that hold the potential for life. Saturn's legion of moons is a kind of miniature universe, offering a variety of environments. Of particular note are the largest moon, Titan, and the small icy moon, Enceladus. These are often discussed with the keyword possibility of life, and are precisely the reason why the Saturnian system attracts interest beyond that of a mere planetary system. Titan, a nitrogen atmosphere and methane seas, a laboratory for the birth of life. Titan is Saturn's largest moon, with a diameter of about 5,150 kilometers, comparable in size to Mercury. Titan's most striking feature is that it is the only moon in the solar system with a dense atmosphere. Its surface atmospheric pressure is about 1.5 times that of Earth's. So much so that a human standing on Titan wouldn't need a pressure suit, though you couldn't breathe. As there is no oxygen, the main component of the atmosphere, like Earth's, is nitrogen, over 90%, with the rest being hydrocarbon gases like methane. Titan's surface temperature is extremely cold, about -179 degrees Celsius, where water is all frozen, solid as hard as rock. Instead, hydrocarbons, like methane and ethane, behave as liquids, and on Titan's surface, methane rain falls, rivers flow, and lakes and seas exist. This means a weather cycle, similar to Earth's, is occurring with different substances. On Earth, water circulates. But on Titan, methane circulates near Titan's north and south poles. There are numerous hydrocarbon lakes, and particularly at the North Pole, there are large methane seas, like Kraken Mare, that are hundreds of kilometers in diameter. In 2005, when the Cassini-Huygens probe landed on Titan, it photographed pebbles made of water ice, scattered around the landing site, and a dry riverbed, evidence that liquid had flowed there in the past. Titan is truly the only celestial body in the solar system, other than Earth, where liquid rivers and lakes exist on the surface. Because of this unique environment, Titan's name frequently comes up in discussions about whether life could exist there. Of course, the temperature is too low for Earth-type life, which requires liquid water. However, a hypothesis of methane-based life has also been considered. The materials for organic matter are abundant in Titan's atmosphere, and on its surface, in the upper atmosphere, solar ultraviolet radiation breaks down methane, producing various organic molecules like acetylene and hydrogen cyanide. These then polymerize to form Tholin's complex organic fine particles, creating an orange-colored haze. This organic haze falls like snow onto the surface, forming sand dunes. Titan is rich in carbon and has the appearance of a laboratory for organic chemistry, precursors to amino acids, the building blocks of life. And complex organic molecules have also been detected in Titan's atmosphere. For example, a NASA report suggests that a molecule called acrylonitrile, or vinyl cyanide, could exist in Titan's upper atmosphere. This has the potential to form cell membrane-like structures in a non-aqueous form, leading to speculation that life with membranes could arise in Titan's methane seas. Whether Titan itself harbors life right now is unknown. However, Titan is also said to have an environment similar to that of ancient Earth, a thick atmosphere, organic matter, energy sources like sunlight and cosmic rays, and the presence of a liquid. Though the scale and temperature are different, there are parallels to the conditions on Earth where life once began. In fact, Titan is sometimes described as a frozen primordial Earth. Earth life uses water as a solvent, but on Titan, methane might play a similar role. If some form of life exists on Titan, it would be a completely different type from life on Earth, and would be a discovery that greatly expands the definition of life, even if no life is found. Titan's organic chemistry will provide valuable clues for thinking about the origin of life. NASA is moving forward with a plan to send another probe to Titan. That is Dragonfly, scheduled to launch in 2027. Dragonfly is a probe with 8 rotors, like a drone, that will arrive at Titan in 2034 and fly autonomously through its atmosphere to survey various locations. Dragonfly is a groundbreaking mission that will land in Titan's dune fields and then conduct mobile exploration by hopping to dozens of sites, including organic-rich surfaces and craters. The goal is to investigate the progress of Titan's organic chemistry, the stage of prebiotic chemistry, and to find out how far the ingredients of life have been assembled. It will also investigate the surface and subsurface environment, and for signs of life evidence that life exists now or existed in the past. Dragonfly will be the first mission in which humanity will operate an aircraft in earnest on another celestial body, and is highly anticipated to get closer to the mysteries of the unique world of Titan, Enceladus, icy plumes, and a subsurface ocean the forefront of the search for life. Another noteworthy moon of Saturn is Enceladus. Enceladus is a small icy moon with a diameter of about 500 kilometers. But in 2005, the Cassini probe discovered jets of ice particles and water vapor erupting from this body, stunning the scientific community. Near its south pole, there are large fissures called tiger stripes, and from there, plumes of water were erupting into space like geysers. What was inferred from this observation was that a liquid water ocean exists beneath Enceladus's surface, an ocean inside a moon covered in ice. It sounds like something out of science fiction, but gravity data and magnetic field observations also suggested that a global ocean extends beneath the surface. It's likely that a layer of liquid water exists between Enceladus's rocky core and its icy crust, and that this water is being warmed by tidal heating from Saturn. Furthermore, Cassini detected organic matter, trace minerals, and hydrogen molecules within the plumes. The hydrogen indicates the possibility of water-rock reactions on Enceladus's seafloor, that is, hydrothermal activity. On Earth's seafloor, rich ecosystems exist around hydrothermal vents called black smokers, and a similar environment could exist on Enceladus. Microorganisms might be able to survive, using minerals dissolved from the rocky core and chemical energy. The conditions on this small moon are such that these imaginings take on a sense of reality. Enceladus is in the spotlight as one of the forefronts of the search for life within the solar system. After all, samples from its subsurface ocean are naturally erupting into space. Allowing a probe to directly analyze the plumes, Cassini actually flew through Enceladus's plumes and measured their components with its mass spectrometer. The results revealed that they contain organic molecules, water, carbon dioxide, ammonia, and the aforementioned hydrogen molecules. The detection of hydrogen is particularly important, as hydrogen, produced by rock-water reactions, is used as an energy source by microorganisms in hydrothermal environments on Earth's ocean floor. In this sense, the ocean of Enceladus could be a cradle of life, similar to Earth's deep sea. Scientists believe it wouldn't be surprising if life existed on Enceladus and are eagerly planning the next mission. While there are no confirmed exploration plans at the moment, proposals for an Enceladus probe are being discussed in NASA's next decadal survey. One idea is a mission called the Enceladus Orbilander, an ambitious project that would orbit Enceladus, collect and analyze its plumes, and finally land to directly study samples. If realized, it would be a historic mission to directly search for life on an extraterrestrial body for the first time. Enceladus is also the source material for Saturn's faint E-ring. Some of the erupted ice particles enter an orbit around Saturn, forming the E-ring that spreads out near Enceladus's orbit. It was also found that some of the water vapor falls into Saturn's atmosphere along its magnetic field lines. Part of the ring rain mentioned in the previous chapter originates from Enceladus. In this way, though small, Enceladus is a linchpin of the water and material circulation in the Saturnian system. From the perspective of searching for life, Enceladus is an entity that teaches us about subsurface oceans and the conditions for life to arise in the cosmos. Other small moons interact with the rings, forming an ecosystem in the Saturnian system. The Saturnian system has a wide variety of moons besides Titan and Enceladus. There are medium-sized moons like Rhea, Tethys, Dione, and Iapetus, moons like Mimas, with a giant crater resembling the Death Star, and even tiny moons that are little more than asteroid-sized chunks of ice. What's interesting is how the interactions between these moons and with the rings make the entire Saturnian system behave like a single ecosystem. For example, there's the cycle where the plumes from Enceladus, as mentioned earlier, to create the E-ring and also cause rain to fall on Saturn. Also, in-ring moons like Pan and Daphnis gather ring particles with their gravity, creating Wakes waves produced behind a moving ship or celestial body, or, conversely, create gaps. Furthermore, we've learned that dust belts and rings, like those observed around the star Fomalhaut, are shaped by moons. Saturn's moons, Prometheus and Pandora, act as shepherd moons for the F-ring, gravitationally confining it and maintaining its width. There are also pairs of moons, like Janus and Epimetheus, that share the same orbit and swap places. In this way, in the Saturnian system, the moons and rings mutually influence each other, maintaining a kind of dynamic balance. Looking at the Saturnian system as a whole, it appears that the smaller moons are primarily made of ice, while the larger moons like Titan have rocky components inside, representing various stages of evolution. It's like a microcosm of the solar system, with the giant planet Saturn at the center, surrounded by various mini-celestial bodies, and even a disk-like ring system. This is similar to the structure of our solar system, with the Sun at the center and planets and asteroids orbiting it. In fact, some scientists say that the Saturnian system is a model case for the solar system. The scale of gravity is different, but the moons orbiting Saturn are like mini-planets, and the rings are reminiscent of a protoplanetary disk. This is precisely the perspective that the Saturnian system is a small universe, from a moon with an atmosphere like Titan to a moon with a subsurface ocean like Enceladus, to moons that create rings and moons that coexist with rings. A diverse collection of worlds is gathered in one place. Truly, Saturn is a microcosm of the universe. Saturn and Earth, the role of an unseen guardian. So far, we've talked about Saturn itself and its moons. But what does Saturn mean for Earth? Have you ever heard that giant planets like Jupiter and Saturn have an influence on life on Earth? In fact, Saturn is one of the unseen guardians in the solar system, protecting us, Earth, from the shadows, a gravitational barrier. As a giant planet, massive planets like Jupiter and Saturn influence the movements of asteroids and comets with their strong gravity. Jupiter, in particular, has been called the vacuum cleaner of the solar system, believed to capture or absorb comets and asteroids that could have been heading toward Earth, or to alter their orbits and fling them into the outer reaches. In fact, in 1994, the comet Shoemaker-Levy 9 was observed colliding with Jupiter, leaving giant scars in its atmosphere. If Jupiter hadn't been there, that comet might have come in Earth's direction. It's widely believed that Jupiter, with its powerful gravity and large gravitational sphere, has reduced the risk of cosmic collisions with Earth over a long period. So, what about Saturn? Saturn is not as massive as Jupiter, but it is still a giant planet with 95 times the mass of Earth. Saturn also influences objects in the outer solar system, such as comets originating from the Edgeworth-Kuiper belt and the Oort cloud. In fact, recent simulation studies have shown that it's not Jupiter alone, but its partnership with Saturn that controls the collision risk for Earth. Research by Kevin Grazier at the American Jet Propulsion Laboratory showed that Jupiter alone might actually pull comets inward. But with both Jupiter and Saturn present, they effectively scatter objects from the outer solar system. This means Jupiter and Saturn, working as a team, form a gravitational barrier, protecting Earth from danger. What's even more interesting is that this research points to another aspect, that is, Jupiter and Saturn not only scatter asteroids and comets, but may have also sent some toward Earth's orbit, delivering water and organic materials, the ingredients for life. It's thought that the primordial Earth had very little water at its birth. But later, water and carbon were brought by the impacts of many comets and asteroids. The gravity of Jupiter and Saturn may have played a role in flinging icy bodies from the outer solar system inward. And as a result, they may have helped Earth to have oceans and for life to begin. Grazier likens Jupiter to Jekyll and Hyde, saying it might be both a guardian and a bringer of the seeds of life, a protector of Earth from comet and asteroid impacts alongside Jupiter, as described above. Saturn, together with Jupiter, is thought to have played a part in shaping Earth's environment and ensuring its safety. In fact, in exoplanet research outside our solar system, there is discussion that planetary systems with Jupiter-class giant planets outside the orbit of Earth-like planets might have a higher probability of being habitable. The idea is that giant planets stabilize the frequency of meteorite impacts and also play a role in supplying volatile materials necessary for life, like water and carbon compounds. For example, in our solar system, about 4 billion years ago, during a period called the Late Heavy Bombardment, countless comets and asteroids collided with the inner planets, including Earth. It's believed that a large amount of Earth's ocean water and organic matter was delivered during this time. After that, it's thought that a slight shift in the orbits of Jupiter and Saturn changed the distribution of the asteroid belt and comets, drastically reducing the frequency of impacts on the inner planets. This means a stable environment arrived on Earth, and a long period of peace began for life to evolve. If Jupiter and Saturn hadn't been there, impact events on Earth might have been more frequent, making it difficult for life to survive. Conversely, the supply of water and other materials might have been insufficient, making the birth of life itself difficult. In other words, it's no exaggeration to say that thanks to the dual guardians of Jupiter and Saturn, Earth was able to become the planet of life it is today. This is not science fiction imagination, but a scenario that is being supported by recent solar system dynamics simulations and findings from exoplanet research. For life to be nurtured in the universe, it's not enough to just have a planet at the right temperature. The surrounding environment, including the supply and defense against asteroids and comets, must also be appropriate. Saturn is far from Earth, but its existence is not unrelated to our own. If Saturn didn't exist, Earth life might not exist. So, as an extreme hypothesis, what would have happened if Saturn didn't exist? Jupiter alone might have had some defensive effect. However, as the aforementioned research shows, there are cases where Jupiter alone could actually cause orbital instability. In a solar system without Saturn, it's possible that Jupiter would have stirred up the objects in the asteroid belt too much and sent a large number of asteroids inward. It cannot be denied that the supply of water to Earth might have been insufficient. Or conversely, that life could not have evolved stably due to excessive impacts. In fact, in simulations of some exoplanet systems, there are results where the presence of too many giant planets causes Earth-like planets to be ejected from their orbits. Fortunately, in our solar system, the placement of Jupiter and Saturn was just right. Therefore, to the question, if Saturn hadn't existed, Earth life might not exist either. Many scientists would answer that it's a possibility, at the very least. It can be said that the current Earth environment has benefited considerably from Saturn's existence. When we look at Saturn shining in the night sky, it's hard to feel a connection to our daily lives. But from a broader cosmic perspective, Saturn is one of the guardians of life on Earth. This can be called the marvel of chance and necessity in the universe, behind our existence right here. Right now, there may have been the quiet work of a distant Saturn, the future of the universe that Saturn shows us. Our story finally moves toward the future. What will Saturn show us from now on? And how does Saturn's fate relate to the future of the universe? In this final chapter, we will conclude by talking about the future of Saturn and the future of humanity, its appearance after the rings disappear, a common planet. As we've seen in previous chapters, Saturn's rings may only have a lifespan of a few tens to a few hundreds of millions of years. So, what will Saturn look like after its rings disappear? Once the rings are completely gone, what remains will be a gas planet that, at first glance, looks a lot like Jupiter. Saturn itself has beautiful cloud bands and a hexagonal jet stream at its pole. But without its rings, its impression will change dramatically. The name Saturn comes from the god of agriculture. But a future where it loses its moniker as the ringed planet is a bit sad. However, on a cosmic timescale, planetary rings may be things that form and disappear. In fact, Jupiter, Uranus, and Neptune also have very faint rings. They are not prominent now, but it's possible they once had magnificent rings like Saturn. After Saturn's rings disappear, perhaps far in the future, new rings might form again. For example, if a new moon breaks apart, planets with rings have also been found outside our solar system. And some have rings far more massive than Saturn's, with radii hundreds of times larger. Such discoveries suggest that rings are not uncommon in the universe. But they don't always exist in the same form. Even if Saturn's rings disappear, its system of moons will remain. Titan and Enceladus will continue to orbit Saturn. However, in the long term, the orbits of the moons will also change. Billions of years from now, when the Sun becomes a red giant, Saturn might have its hot atmosphere stripped away. At that point, the absence of rings will be a trivial matter. But Saturn itself is not eternal. Ultimately, whether the planets will be scorched as the Sun expands, or the solar system will be torn apart by the galaxy's tidal forces, a grand future awaits. The disappearance of Saturn's rings is just one episode in the vast impermanence of the universe. Future exploration plans, Dragonfly, and beyond. Speaking of the future, We can also look forward to the plans for humanity to send probes back to the Saturnian system. The aforementioned Dragonfly is a prime example. Dragonfly is a grand mission to fly on Titan and search for the ingredients of life. If successful, it will be the first time an aircraft like a helicopter is flown on another celestial body, marking a new chapter in the history of human exploration. We can also expect mission proposals for Enceladus to take shape in the future. If signs of life are found in the subsurface ocean of Enceladus, it could be the greatest discovery of the 21st century. The Saturnian system, along with Mars, is a key target in the search for life within the solar system. On Mars, we are searching for traces of past life, but in the Saturnian system, Titan and Enceladus, there seems to be a potential for ongoing or potential life. There are many other ideas for Saturn exploration. For example, a plan to send a probe into Saturn's atmosphere itself, like the Galileo probe for Jupiter. To directly measure atmospheric composition and winds, Cassini grazed the upper atmosphere of Saturn, but did not go deep. In the future, sending a dedicated atmospheric entry probe to Saturn would further unravel the mysteries of its internal structure and formation. Speaking of Saturn's moons, there are even dreams of a manned mission to Titan. Titan has a thick atmosphere and high surface pressure, making it relatively hospitable for humans in some respects. Although the extreme cold and lack of oxygen are fatal problems, Titan is also discussed as a potential future remote base for humanity. For example, the hydrocarbon resources on its surface, like methane and ethane, could be used as an energy source. And since there is water underground, it could be broken down to obtain oxygen. There's even the bold opinion that Titan's atmosphere protects against radiation, making it a safer habitat than Mars. The concept of floating cities on Saturn, could it be humanity's second home, expanding our imagination even further? There's the concept of floating cities on Saturn. Saturn itself is a gas planet, so there is no surface to land on. But conversely, there is a vast ocean of atmosphere. Theoretically, it's not unthinkable to use buoyancy in Saturn's atmosphere to float giant cities or platforms. In fact, NASA once conceived of the Havoc project, a plan to float airship-like cities in the atmosphere of Venus. Applying the same idea to Saturn, we can draw a sci-fi future where human habitats are built above Saturn's clouds. Of course, the inside of Saturn's clouds is a harsh environment for humans, with ferocious winds, storms, and extreme pressure and temperature. Realistically, it's not a place people can live in immediately. However, its potential as a site for resource extraction is being discussed. For example, the atmospheres of Saturn and Jupiter contain helium-3, which is anticipated as a fuel for nuclear fusion. Though the concentration is very low, depending on future energy demands, atmospheric airships to collect helium-3 from Saturn's atmosphere might appear. A floating base would serve as a hub for that. A floating city on Saturn is purely at the conceptual stage, but the Saturnian system holds the potential to become an important second hub. As humanity expands into the solar system, Titan, in particular, is a candidate for a future colony because it is a world with a stable atmosphere and terrain, second only to Earth. A future is envisioned where permanent bases are built on the surface, boats float on methane seas, and drones fly in the sky. Even if we can't land on Saturn itself, the day may come when we view the spectacle of its magnificent rings from a city floating in the sky. If humanity can advance into the Saturnian system before the rings disappear, we will be the civilization that witnesses the moment of the rings' demise. That would be a grand drama to participate in cosmic history. Saturn gives humanity many questions and dreams. We should continue to watch Saturn as a potential domain for future human activity. We have explored the multifaceted charm and mystery of the planet Saturn and its relationship with humanity. Finally, let's summarize today's journey. Saturn, at first glance, seems like an anomalous planet. There is no other planet with such enormous rings, and its collection of moons is full of unique worlds. However, as we have seen, those rings were, from a cosmic perspective, a fleeting miracle. Its moons were as diverse as a microcosm of the solar system, and they even held the potential for life. We learned that Saturn's own internal structure is ambiguous, an existence that transcends conventional wisdom, and Saturn has acted as a guardian for life on Earth and suggests possibilities as a sphere of activity for the future of humanity. In other words, Saturn was not an anomalous planet, but a microcosm of the universe itself. To know Saturn is to get closer to fundamental mysteries, like the origin of the universe, the conditions for life, and the evolution of planetary systems. Ever since Galileo first saw its strange form 400 years ago, humanity has been captivated by Saturn. From now on, Saturn will continue to provide us with new discoveries and surprises. Finally, for you, is Saturn a beautiful illusion? Or is it the key to unlocking the universe? Try not to just gaze at Saturn, but to contemplate the drama hidden behind it. The light of Saturn, shining in the night sky, may be telling us a part of the grand story of the universe. Thank you for watching until the end. If you found this video interesting, please subscribe to the channel and give it a high rating. Also, this channel, Cosmic Lab, is able to grow steadily thanks to the support of all our viewers. Thank you so much for your continued support. We have set a challenging goal of reaching 100,000 subscribers by the end of 2025 and are working hard on video production every day. If you haven't subscribed yet, we would be happy if you would subscribe and continue to support us. We look forward to seeing you in the next video.